Let's review a normal force. A normal force is a line that is perpendicular to a surface. So, here is a surface, and here is a line that is perpendicular or 90 degrees to that surface. It is called a normal line. Now, the normal force is the reaction force of the lower surface to the upper surface. So here's a rock pushing down on the lower surface, the earth. The weight pushes down, and the ground pushes right back up to match that weight. And that is called the normal reaction force. We usually just say the normal force. And in this case, the normal force is simply equal to the weight. Now, suppose a big finger came down and pushed on that rock, added an additional force downwards. If that happened, now the normal force is increased by how much the finger pushed. So the normal force is the weight plus that extra push. Now let's look what happens when we pull an object at an angle. So here's an object, and we pull it with a force P at an angle. Now in this case then, we still have the weight pushing down on the surface, but there's the vertical component of that pulling force that reduces the effect of the weight. You can see it there. The full effect of that weight would not be felt by the surface now. It is reduced by the upward pull of that vertical component. So there's a lesser effective force pushing down. You can see it with that yellow arrow. Now, how do we find that effective force down? Well, first of all, if that's angle theta, that vertical component then would be the opposite side P sine theta. Therefore, we have P sine theta reducing the weight. The force down then is equal to the weight, which is mg, minus that upward component P sine theta. That is the effective downward force. Well, if that's the effective downward force, there's now a reaction force, mg minus P sine theta. There's the effective down force. There's the normal reaction force, mg minus P sine theta. Now let's look what happens when we push at an angle. We have pulled, now we're going to push. Now we still have the weight W acting down, but this time we have the component of the push force acting down. Therefore, the weight plus the component of the pushing force downward will add to the total effective downward force. If that's theta, that side is P sine theta. Therefore, acting down, we have P sine theta plus the weight, mg. The total down force then is mg plus P sine theta. And therefore, if the total downward force is mg plus P sine theta, that must equal the reaction force, the normal reaction force.